In lesson 30, linear systems and three variables, we're going to start with example number 1. That means we're going to skip exercises 1, 2, and 3. Those are optional. If you want to do those, then do those. But what we're going to do is we're going to focus on a three-variable linear system where we have an x, a y, and a z. So solving this is not complicated. It's kind of like doing the elimination system 3 times in a row. And so I'm going to model this. I'll show one that looks like this one. We'll show a third one, which will be exercise 4. And then I'll walk you through exercise 5. But this will be the example that we're going to focus on. The easiest way to deal with and manipulate this is to take the equations and start by labeling this as 1, 2, and then 3. And what we're going to do is we're going to combine pairs of equations at a time with the goal and choice of eliminating only one type of variable first. We're going to choose to eliminate the z's because the z's seem to have a nice pattern to eliminate. So we're first going to choose equations numbers 1 and numbers 2. So if we write number 1, I'm going to write 2x plus 3y minus z equals 5. Then I'm going to write 4x minus y minus z equals negative 1. Again, our goal is going to be to eliminate the z. So by doing that, I am going to choose to subtract the first equation with the second equation. That result is going to give me negative 2x, a positive 4y. The z's will eliminate, and then we're going to get a 6. So again, that is by combining the first and the second equation together. So we're going to go through this process again, but this time we're going to combine equations numbers 2 and equations number 3. So equation 2, which we already know, is 4x minus y minus z equals negative 1. And then the third equation is x plus 4y plus z is equal to 12. And then our goal is to, again, eliminate the z variables. Now, in this case, the z's are opposites, so we're going to add each column. And so 4x plus 1x is 5x. Negative 1y plus 4y is 3y. And then negative z plus positive z is 0. That cancels, which is what we want. And then negative 1 plus 12 is equal to 11. Now again, this was our goal. Our goal was to eliminate all the z variables. We did that by combining the first 2 equations and then combining the second 2 equations. And so now we're going to take those results, which is negative 2x plus 4y equals 6, and 5x plus 3y equals 11, and we're going to solve for x and y like we traditionally would. And so you just kind of make your choices. I'm going to choose to eliminate the x's in this case. And so when I do that, I'm going to multiply this first equation by 5. I'm going to multiply this second equation by 2. And so my 2 brand new equations will be negative 10x plus 20y equals 30. My second equation is going to be 10x plus 6y equals 22. Now, with that being the case, I am going to add these 2 columns together because my 10s are opposites. That's going to eliminate the x's, so that would be 0x, and then 20 plus 6x, or y, is 26y. And then 30 plus 22 is equal to 52. We'll divide both sides by 26, and y will equal 2. So now that we have the y variable, we're going to plug back into the x. We can use either one of these equations that we want. I'll choose the second one. And so I'll say 5x plus 3 times 2, and that's going to be equal to 11. And so now I have 5x plus 6 equals 11. Well, minus 6 on both sides. So 5x will equal 5. And divide both sides by 5. And x will be equal to 1. So now we know 2 of our 3 variables. Now that we know our x and we know our y, we're going to go back and pick one of these 3 original equations, plug in x and y, and then solve for z. For simplicity's sake, I'm just going to pick equation number 1. And so I'm going to say that 2 times 1, because we know that one now, we plug that in, plus 3 times 2, and then minus z, and that's going to equal 5. So we'll simplify. This becomes a 2. This becomes a 6. We have a minus z equals 5. So now we have 8 minus z equals 5. And then we subtract 8 to the other side. We'll get negative z equals negative 3. And then we divide by negative 1, and z will equal to 3. That makes our final answer in the order, so we'll say what final answer would look like this. X is 1, so 1 comma y is 2, and z is 3. This one ends up being 1, 2, and then 3 in that order, and it follows in the alphabetical order, or the order of the equation x, y, and z. This is the traditional pattern that normal 3-variable systems follow, where again we wrote down equations numbers 1 and 2, chose the variable we're going to eliminate and eliminate it, and then we write equations 2 and 3, keeping in mind you have to eliminate the same variable you did for the previous one. That's going to take you to a standard system that only has 2 variables missing, and again you would solve with elimination to get 1 variable, and then you start to backwards fill to get the remaining variables that are in the equation that you're going to solve for. So again, this is mainly what you're going to do. Some systems are easier than others. Sometimes you have to think or be a little bit creative where you might want to swap equations or anything like that, but this will be your general case that we're going to practice. But keep in mind the problem set may have one that's a little bit trickier that you might have to use a little bit more thought in. If we looked at exercise number 4 and took a look at it, you're going to see that this system is going to solve a little bit simpler. But the process we're going to use is going to stay the same. We're going to label this one number 1, this one number 2, and we're going to label this one number 3. So let's see what happens if we put 1 and 2 together. So equation number 1 is going to say r plus 2x, or actually that's not an x. There is a typo that we need to correct and address. This is not actually an x, this is actually an s. It would not be good news for us if it was actually an x. So 2s minus u equals 8, and then we're going to have s plus u equals 4. And so we're going to choose to eliminate a variable that's going to make this one work out. And it seems like we may not want to do that looking at this one. What may work out better is, and this is where I warned about special cases, is instead of doing 1 and 2, in this choice, I'm going to choose to bring together 1 and 3. And so the reason why I'm doing that is because there's no r value here. And so I want to try to avoid using that if I can. And so now if I bring in equation 3, we have r minus s minus u equals 2. Now what you're going to notice when I solve this one, I've got r's that are exactly the same, and I've got u's that are exactly the same. So I'm going to choose to subtract the columns. R minus R goes away. 2s minus s, in this case, is going to be 3s. And then negative u minus negative u goes away, and 8 minus 2 is 6. And so now I do 6 divided by 3. All of a sudden, I know what s is already. And so s is equal to 2. Now, if I go in, I look at these things again, I'm going to choose to combine this time equations 2 and equations 3. And so 2 is going to say s plus u equals 4, and then the other one's going to say r minus s minus u equals 2. And the reason why I'm making that choice, if you notice the variable patterns, the s's are opposites and the u's are opposites. So I'm going to choose to add these columns. And when I do that, we're going to have s's canceling, u's canceling, and we're going to find out that r is equal to 6. So again, you can see this system's different than the last one. We have to be a little bit more cautious about which ones we choose to combine. In this one so far, I've chosen to combine 1 and 3 instead of 1 and 2. And I decided to combine 2 and 3 because it allowed me to solve for r. And now that I know s and r, I can use that to figure out u. Now again, I don't even really need r to solve for u, because if I was to choose equation number 2, s plus u equals 4, I already know what s is. S is 2. And I need to find the u. And so all I have to do is subtract that 2 to the other side and find out that u is equal to 2. And again, our final answer is going to look like this. So we'll say final answer. Let's write that as parentheses. Again, we're going to write it in order, r, then s, and then u. Our r is 6, the s is 2, and the u is 2. And so this is another system that's a little bit different than the first. I tend to call this a special case where it doesn't follow the 1, 2, and then 2, 3 pattern, to where you find things that look like they mix well together and then solve. The final exercise is where they want us to be able to figure out an equation such as this one, y equals ax squared plus bx plus c, and then they give us 3 points on the graph that wants us to make sure it goes through those equations. So what we want to make sure we note right away is that this is an x and a y. This is another x, and this is a y. This is an x, and this is a y. The reason why that's important is we're going to write 3 equations. We're going to actually create that system. It says y equals ax squared plus bx plus c. The a, b's, and c's are what's going to actually be missing and what we're going to actually plug in. So to do that, we're going to plug in the first equation, the 1 and the 6, everywhere there are x's and y's in the equation. So the first one's going to say 6 equals, and then 1 squared is 1, so you're just going to end up with a, and then 1 times b is b, and then you have a c at the end. We're going to do this for the next equation, 3 and 20. So we're going to plug 20 in for y, set that equal to 3 squared, which is 9, and so you have an a that goes with that, and then 3 times b, so we're going to have 3b, and then we're going to have a c in the end. You'll probably notice as we're building this, there's a plus c and a plus c. That's going to be the first variable we're going to choose to eliminate, much like the z's in the first example. So now we do this one more time. We're going to plug in 15 equals, and we have negative 2 squared is 4a, and then negative 2 times b is negative 2b, and then we're going to have our c. This creates the system off of those x's and y's. Now remember, our goal is to find an equation. In this case, it's a quadratic equation that is going to pass through those 3 points. By solving for this system, a, b, and c, we're going to be able to find that equation. So this starts off like the first example now that we're at this point. We're going to label this 1, we're going to label this 2, and we're going to label this 3. And so we're going to start by doing the exact same thing we did previously. We're going to start by using equations numbers 1 and 2. And so we'll write down the first equation, 6 equals a plus b plus c. And write down the second equation, 20 equals 9a plus 3b plus c. And we're going to solve. We're going to eliminate the c's. So to do that, we are going to subtract each column. So we'll put a minus sign out in front so we can subtract. And so 6 minus 20 is going to be negative 14. And then a minus 9a is going to be negative 8a. B minus 3b is negative 2b. And then the c's are going to cancel. So then we're going to do the same thing again, but this time we're going to switch it over to equations numbers 2 and 3. So write down equation number 2 again, which is 20 equals 9a plus 3b plus c. The third equation is 15 equals 4a minus 2b plus c. And what we're going to do is we are going to subtract these as well to get rid of c. So again, I like to put the parentheses here. We'll change the color. We'll put a minus sign in front of there as well. So 20 minus 15 is 5. 9a minus 4a is 5a. 3b minus negative 2b is 5b. And then you got c minus c, and that cancels out. This is going to create our 2 other systems that we're going to solve. So now when we write those, that means we now have negative 8a minus 2b equals negative 14. And then you've got 5a plus 5b equals 5. We're going to solve this system. This time, let's say we get rid of the b's. So we're going to multiply the first equation by 5. We're going to multiply the second equation by 2. And so that's going to yield us a negative 40a minus a 10b equals a negative 70. The second equation is going to yield a 10a plus a 10b equals 10. And then we're going to solve. And so since these are opposites of one another, we are going to add these columns together. And so it's going to give us negative 30a. These will eliminate. And then negative 70 plus 10 will be negative 60. We'll divide by negative 30 on both sides and find out that a is equal to 2. Now that we have a, we're going to pick one of these 2 equations that we worked on right here, the ones that we originally created here in blue. I'm going to choose the second one, and we're going to plug back in. So we're going to say 5 times 2 plus 5b is equal to 5. And so that's going to give us 10 plus 5b equals 5. We're going to minus 10 to the other side, so 5b will equal negative 5. And divide by 5, b will equal negative 1. So now we have a, and now we have b. If we want to find c, the easiest equation here would be number 1, where you've got 6 equals a plus b plus c. Well, that's the one we're going to use. So now we know if we've got 6, and we know a is 2, we know b is negative 1, so it's minus 1, and then we have plus c, you're going to have 6 equals 1 plus c. We're going to minus 1 to the other side, and c is going to equal 5. So final answer, remember the final answer here was to write an equation that would work. So that final equation is going to say y equals, we now know the a. The a we said was 2. So we're going to have 2x squared. We know the b is negative 1. So it's going to be minus 1x or just minus x. And then we know the c, which is right here, which is 5. And so then we're going to put plus 5. That would be final answer for what we are attempting to do. Alright, so again, remember, if you need to watch the video again, watch the video again. You're going to be working on problem sets numbers 1 through 8. If you get done and you want to try 9 and 10, that's great, but really you need to be able to do numbers 1, 2, 3, 4, 5, 6. Let's just stop at that. I'll leave it at that. Let's leave it as 1, 2, 3, 4, 5, and 6. Let's not worry about 7 or 8. Again, some of these in the problem set are going to be traditional, like where we labeled them 1, 2, 3, and you did 1 and 2 and 2 and 3. And some of them are going to be like the exercise number 4, where you need to study the system and figure out maybe 1 goes better with 3, or something like that, and think about it. And of course, persevere to get to the final answer. So again, take your time. Hope this video helps.